Hello everyone, my name is Maria Yara and together with my teammate Sebastián Pedraza and Gustavo Pinto, we present our machine learning project PatrimonioCO. This is prediction system of structural deterioration of Colombian architectural heritage assets. We apply the CRIS-ML methodology to end. The application is developed live OneRender.com. Let me start with phase one, business understanding. Colombia has over 1,000 registered cultural heritage assets BICs, including colonial churches, historic centers, and centuries-old elder buildings. These structures are exposed to climate pollution and urban traffic. The current model is purely corrective. Authorities only act after damage occurs. This is expensive and results in irreversible loss of cultural heritage. Of project transform this predictive model into a preventive data drive one using machine learning on open environmental and urban variables. Our main object is to predict the deterioration level, low, medium, or high of any age building using only open data. Object 1, develop a classification model for any peak. Object 2, reduce corrective maintenance cost. Short L identification. Object 3, give mean cultura and ADPC, a data-driven prioritization tool. Object 4, document the full process under CRIS ML for reproducibility. Object 5, prove that open data alone is sufficient for prediction. The model answers critical questions such as which material and pollution combination accelerates deterioration most? How does road proximity affect buildings over 200 years old? The project is high speed. All data is open source, even for climate, OpenStreetMap for roads, Datos Abiertos Colombia for H, heritage, no private or costly data required. I will now present phase two, data understanding. For this project, we select dataset Patrimonio Colombia 1,200 CSV. It contains 1,200 records of cultural heritage assets from two Colombian sites across 8 departments. As you can see here, 11 columns, zero nulls, evaluates, zero duplicates. Cities include Bogotá, Medellín, Cartagena, Villa de Leyva, and Bichara, representing different macroclimates across Colombia. The dataset has 5 numerical variables, capturing environment, a structure rising 50 to 385 years, main 150 annual precipitation 400 72 and 2,260 millimeters, and variable humidity 51 to 99% accelerates corrosion and mold. PM10 particulate matter relate to acid rain and distant to main road or proxy for mechanical vibration rates. The target variable is current deterioration left low 713 records medium 469 height only 18 just 1.5%. This class imbalance is a key chain address in data engineering. Here you can see the full statistical summary common standard deviation, main qualities, and max for each variable. The distributions show coral, stone, and adobe have 53 to 57% medium or high deterioration, the most vulnerable materials. Bogota and Medellin show 60, 60 to 62%. Bichara only 70%. The person correlation matrix confirms two correlations between prediction. Maximum 0.2066 between prediction and PM10 no significant multicorrelati. I know pass to Sebastian for fast 3 data engineer.
Thank you, Maria. I will now explain how prepare the data engineering and machine learning. We applied for street cleaning and rules. You can see the Python code here. Rule 1 is we clipped negative PM10 values to 0, physically impossible. Rule 2, we filtered structure age to 50 to 450 years, removing 3 outliers. Rule 3, we confirmed 0 null values programmatically. Rule 4, we validated relative humidity never exceeds 100% after cleaning 1,197 valid records ready for transformation. For categorical variables, we applied one hot encoding to main material and city, generating 16 new binary columns visible here. The target was label encoded low equal 0, medium equal 1, high equal 2. Most importantly, we create 2 new engineered features, the acid rain index, precipitation times PM10 divided by 1000. This captures the combined degradation power of rain through polluted air and the vibration risk index structurage divided by road distance. This capture how old buildings near highway suffer more mechanical damage. These two features will prove be the most predictive variables in the model. Here can you see variables we included and which excluded. And the feature engineering identifiers like building ID and heritage name we remove. No predictive value for normalization standard scalar was applied to all numerical variables for logistic regression and KNN models sensitive to future scale. Random forest doesn't require scaling since it is tree-based. All transformations are documented in pipeline log shown at the bottom. Final result 1,197 records, 27 columns, fully ML ready. I will now continue with phase 4, model engineering. At the model engineering, uh, we split dataset 80, 80% by 20% using stratifier sampling, uh, 960 records for training and 240 for testing. Stratified means the low, medium, and high. Ratio is preserved in both sets. We selected 3 models from completely different algorithm families. Model 1, random forest, and ensemble of 100 decision trees. It handles class imbalance natively and gives feature importance. Model 2, logistic regression, our linear interpretable baseline. And model 3 is KNN, distance based, classifies by its 7 nearest neighbors. Here is the complete training code and for all models. For random forest, 100 estimators, max depth 10 to prevent overfitting, class weight balanced critical because height is only 1.5% of data. For logistic regression, C equal 1.0 balanced regulation, max iter equal 1000 to ensure coverage on our high dimensional dataset for KNN 7 neighbors ought to avoid typos, Euclidean distance. All models use random seed 42 for full reproducibility. Here's the comparison table for all 3 models. And here is 5-fold cross-validation output. Random forest 89.58% means CV accuracy, only 0.4% variance. This small variance across faults confirms overfitting. Logistic regression 82.71%, KNN 73, 0.65%. All 3 models were saved as PKL files using Jobly for production. I now pass to Gustavo for phase 5 model evaluation.
Thank you, Sebastian. I will now present the model evaluation. This is a multi-class classification problem, low, medium, or high. So we use 6 classification metrics: accuracy, precision, recall, FA1 score, AUC, REUC, and confusion metrics. Regression metrics, um, regression metrics like MAI or RMCE are not applicable here because our output is a category, not a continuous number. Here you can see the evaluation dashboard for all 3 models. Random forests achieved the best result across every single metric. Here, wait. Okay, here is the full comparison table. Random forest accuracy is 88.33%, precision 87.28%, F1 is 87.76%, AOC ROC is 0.9571, and sorry, and logistic regression accuracy is 82.50%, AOC is 0.9150. Now, looking at the confusion matrix, random forest correctly classified is to to 13 of the to further test records. The main error is low and medium confusion. 25 case, an important limitation. All models struggle with the high class because it only has 20, 10 28, sorry, is um, the judges, sorry, training records, and 1% class imbalance. The OEC ROC chart shows random forest of 0.9571 near excellent. Logistic regression at 0.9150, KNN at 0.8382. All models are significantly better than random guessing. Based on our six metrics, we selected random forest as our production model. As shown here is accuracy, best AOC, most stable CB scores, feature importance for interpretability, no scaling record, and native class imbalance handling. I will now demonstrate the live prediction system. The go or Flask application at the project for the link my by my render. As you can see the navbar at the 6 group simulate BASF menu. Each menu links directly the correct flex page. The application structure follows the methodology exactly. Business understanding, data understanding, data engineering, model engineering, model evaluation, and prediction system. I'll see. This is prediction system, the core of our application. The user can input six variables manually: structure age, main material, annual precipitation, relative humidity, painting pollution, and distance to main road. We also provide three examples scenarios at top for quick testing. Please, in the see for the next days is age, material, precipitation, humidity, PM10, and rad distance. The values is the video for view is the example. This is represented worst case scenario for unhealthy buoyancy. The model returns predict deterioration level high in this case, below that the confidence percentage from the random forest model. And here you can see the probability bars for a tree class. Low probability, medium probability, and high probability. That gives the user full transparency about the model's certainty. The system also includes user-friendly error handling. If your requery is missing or at invalue, and and clear error message here, not a Python crash. This ensure application is robust and a type of user input. Okay, let's go now is no, here repository for the code is available in the link the GitHub. The repository contains app.py with the Flask routes. You can see heritage model.py with the training and the prediction logic. We can see the templates for with a 7 HTML page, business understanding, data engineering, data understanding, heritage application, layout, model engineering, model evaluation. And requirements.txt, sorry, point.txt with the all dependencies for installation by run and Flask. The commit history shows progressive development, fair crisp emblem phase. The application is deployed on random.com using Unicorn. First startup flags automatically, trains the three models, and saves them as PKL files for fast subject predictions. To conclude, Patrimonio CO demonstrates that machine learning can transform heritage conservation from the reactive to preventive. Using only open data source, random forest with 88.33% accuracy and 0.9571 AUC. Reliability predicts low and medium deterioration, covering 98.5% of all heritage. Our two engineering features account for 31% of predictive power. Validating the domain knowledge applied in data engineering, future work should focus on collecting more high deterioration cases to improve detection of the most critical heritage assets. Thank you very much. Our application is like project render, source codes in GitHub, and this video is on YouTube.